Hi, and welcome to this Kc unstructured calculation question, starting from masses of reactants, which is slightly unusual as opposed to concentrations or volumes. So it includes the use of the ICE method, and I'll just explain in a moment when we start on the ICE method why it's called ICE, if you haven't come across it before. So you can see it says the student carries out a second experiment to determine the value of Kc for this reaction. Obviously, it's a section of question, so let's just bring up the equation from before. So the student mixes 9.6 grams of methanol with 12 grams of ethanoic acid. So let's pop those above the two reagents in question. So the ICE method is for using the initial moles, the change in moles, and the equilibrium moles. So we use mass over MR for the masses to get the moles. So it should be quite easy to work out the MR and then divide the mass by that. So I'm going to color code the numbers I put into my ICE table. The ones in pink are from the question, and the ones in black are deduced. So it tells us that when the mixture reaches equilibrium, 0.030 moles of ethanoic acid remain. So straight away, at the start of the equilibrium, we can assume that there is no methyl ethanoate, and there's no water. So I'm putting in 0.00 on the right-hand side for both of those in black. So it tells us in the question that the number of moles of ethanoic acid at equilibrium is 0.03. So the difference between that and the initial starting moles was 0.17. So 0.17 moles have been used up, hence the minus sign in front. Now in the equation, the methanol is equimolar to the ethanoic acid, so you will also lose minus 0.17 moles of that. At the same time, you will get the same number of moles of ethyl ethanoate and water made on the right-hand side. So that allows us now to have our moles at equilibrium. So normally we want to convert these into concentration, and we do that by doing moles over volume. In the question, there's no volume given, so you assume it's 1 decimeter cubed, I beg your pardon, for simplicity. So writing out a Kc expression, the first thing you might notice is that water is present. So its concentration is not disregarded this time because it's not in large excess as it would be if everything was aqueous. So if all the other things were aqueous, we'd assume there would be a very, very large excess of water, so therefore very little change to its concentration by the production of 0.17 moles of it. But everything's in liquid form here, so you have to take that into account. That might be something that would trip some people up if they try this question and don't do that. So now what we can do is to put some numbers in, and you can see quite clearly that there's two terms on the top and two terms on the bottom. So therefore the volumes will cancel out. So that's not the case every time. It is the case in this instance because in the Kc expression you can see there's two concentration terms at the top and two concentration terms at the bottom. So units will also cancel each other out. So the next thing to do is to put the numbers in. So you can see I've cancelled out the 1.0. That gives me 7.41. I'm actually going to put down no units because that shows the examiner that I've taken that into account. I haven't just put 7.41, I've put in brackets no units. So on the mark scheme it says first check the answer line, and we got 7.4. But it allows up to calculate your answer of 7.41, etc., etc. So 7.41 is fine for giving ourselves 4 marks on this one. Okay, as always, thanks for listening. Until next time, see you soon.